For example number 5, you're hiking towards the main road, but reach a point where the road is flooded. So here's our original road. We're hiking towards the main road. We reach this flooded area. Big flood there. So we're going to take a 48-degree turn. 90 would be straight across. So that's why it's called a 48-degree. It would be small. And we're going to walk at a diagonal. The diagonal is a total of 3.6 miles. How far were you from the main road when you turned onto the diagonal road? So we're trying to figure out how long X is from about there down to the main road. Well, this is a right triangle. We have an angle of 48 degrees. The side next to it, the leg next to it, would be called the adjacent side. Across from the 90 would be called the hypotenuse. So using SOHCAHTOA, we know that cosine would be adjacent over hypotenuse. So cosine of 48 equals the adjacent side over the hypotenuse. Put it over 1, cross multiply, 3.6 times the cosine of 48 equals our x value. When we multiply those two together, we get 2.41, and that's our x, and that would be in miles. On the flip side, we're looking here at the diagram. It's just giving us some notes on what is the angle of elevation compared to the angle of depression. If you look up at an object, so if we look at the top of the building, angle of elevation is your angle line of sight that's done with the horizontal. So looking up compared to the horizontal, that would be your angle of elevation. Now if you are on top of the building, looking straight out, your angle of depression would be the angle at which you look down. Now a common mistake is for people to think that the angle of depression is the other acute angle of the right triangle, and that's not true. Actually, the angle of depression and the angle of elevation are the same to each other. This is a zigzag, so they're alternate interior angles. So they're the same measurement. The horizontal land should be parallel to the horizontal horizon. One thing you need to remember, that you're always comparing this with the horizontal line. So your angle of elevation is off the horizontal, that's the angle that's formed, and your angle of depression is off the horizontal. So always remember the elevations of elevation and depression are measures from the horizontal line. The angle has to touch the horizontal line. So from a point on the ground, 28 feet from the base of a flagpole. So we'll put a little ball up on top of a flagpole. Put a flag there. So there's our flag. We have from the base of the flagpole 28 feet. The flagpole would be standing straight up at 90 degrees. We would have a right triangle that's formed. The angle of elevation is 63. And we want to find to the nearest foot what the height of the flagpole is. So looking across from the 63 is our opposite side. next to the other leg next to the 63 is called the adjacent side. So SOHCAHTOA tells us that we're going to use tangent of 63 equals the opposite over the adjacent. So we'll take that, we'll put it over 1, we'll cross multiply. So that gives us 28 times the tangent of 63. That equals x, which using our calculator is 54.95. So rounded to the nearest foot, we would be at 55 feet. Next, we're going to take a parasailer, and it's attached to a boat with the rope that's 300 feet long. So we're going to take a boat, put a motor on the back of that boat. We'll hook a little platform up and put your 300-foot line off the back. Connect your parasailer, which you're just hanging there, and make a right triangle out of that. We know that the parasailer, the angle of elevation from the boat to the parasailer is 38 degrees. We know that the rope is 300 feet long. To the nearest foot, how high is the parasailer? Well, we're trying to figure out that value. So we're going to look across from the 38, which is opposite, across from the 90, which is the hypotenuse. So SOHCAHTOA tells us that it's opposite over a hypotenuse. So sine of 38 equals opposite over hypotenuse. Put it over 1, cross multiply, 300 times the sine of 38 equals x. When we use our calculator, we get 184.70. You always want to write the exact value down. And then it says to round it to the nearest foot. Well, that's closest to 185 feet. Last question. From a point on the ground, 64 feet from the base of a tree, there's our tree. From the base of the tree, we're 64 feet. The angle of elevation to the top is 28. To the nearest foot, what is the height? So again, we're going to use opposite. Your right angle would be that the tree is standing up perpendicular to the ground. So your hypotenuse is on this side, the adjacent side is the other leg that makes the angle. So we're using opposite and adjacent. Opposite and adjacent gives us tangent of 28 is x over 64. Put that over 1, cross multiply. When we calculate that, we get 3403. And to the nearest foot would be 34 feet. That's how tall our tree is. I want to show you an additional example of us finding the measure of an angle. Here would be a situation where we're given a right triangle. We have a right angle. Across from the right angle is the hypotenuse. If we're looking for the measure of angle A, across from theta, or our angle, is the opposite side. Next to it is considered our adjacent. So we know that we're going to use, thinking of SOHCAHTOA, that the opposite and adjacent would be tangent. So just like before, tangent of theta, you could say, or tangent of A, whichever way you like to write it. Tangent of theta equals the opposite over the adjacent. So we know the tangent is supposed to give us this ratio of 3/4. Well, there's only one angle that could possibly give you an opposite over adjacent that is 3/4. Or you could call that 0.75, because you would have the same angle if it was 6/8. It has to be a reduced fraction down to 3/4. But regardless of the measurements, 5 and a 7, a 2 and a 1, whatever the measurements were, you would always say, set up your trig function the same way. We want to get the angle by itself. So we are going to move the tangent to the other side. So to do that, we are going to say the angle equals tangent inverse of 3 divided by 4. You learned this in geometry class. So we'll bring over our calculator. Be sure you're in degree mode. So we'll say second, have to hit the second button, tangent, 3 divided by 4. If you're doing a fraction, it has to be in parentheses. Most of the graphing calculators put that in automatically. So we know that we're going to be 38.87 degrees, 36.87 degrees. The measure of angle A equals 36.87 degrees. Let's try another one. So if we know we have a length of 5 and a length of 13, we're looking for the measure of angle A. So that's our theta. So across from theta is always the opposite side. Next to it is always the adjacent side. Across from the 90 is the hypotenuse. So using SOHCAHTOA, we know that we would use cosine of angle A equals the adjacent over the hypotenuse. To get the measure of angle A by itself, we're going to do the inverse. The inverse moves cosine away, so now we have the measure of angle A, got A by itself, to be cosine inverse of 5 divided by 13. We take our calculator. Be sure you're in degree mode. Cosine inverse, you got to be sure it says -1. 5 divided by 13. That gives us 67.38. So the measurement of angle A equals 67.38 degrees. If you know two sides of your right triangle, you can calculate the angle by doing the inverse. I'll do a last example. If you have a right triangle and we have some side lengths of 9 and 15, we're looking for the measure of angle A. We know across from our A is our opposite side. Across from the 90 is the hypotenuse. So SOHCAHTOA reminds us that we're looking at the opposite and the hypotenuse, which would be sine. So sine of our theta equals the opposite over the hypotenuse. So here we don't know what the angle is, so there's nothing to type into the calculator, no reason to cross multiply. We don't know what the angle is. So to get the angle by itself, which happens to be angle A, we're going to use the measure of angle A, because that's where theta is located, equals sine inverse, because that moves the sine to the other side, of 9 divided by 15. So second sine, just got to say sine -1, which is sine inverse, of 9 divided by 15 gives us our 38, I did it again, 3687. You might recognize that that matched another example we had above. It's because the triangle I had above was a Pythagorean triple of 3, 4, and the missing side must have been a 5. And down here, I have 9, something, and 15. Well, 9 and 15 are multiples of 3. 3 times 3 is 9, 3 times 5 is 15. So this is truly a 3, 4, 5 triangle. So it's the same type of triangle, and I was looking for the side opposite the 3. It happened to be the same measurement. The triangles are not congruent, but they are similar to each other. Therefore, the angles are congruent and the sides are proportional. These are inverse trig functions.